Find the limit. The limit of cosine of x minus 1 plus 1/2 x squared divided by x to the fourth as x approaches 0. If we try the quotient rule, we'd be taking the limit cosine of x minus 1 plus 1/2 times x squared as x approaches 0 divided by the limit of x to the fourth as x approaches 0. The numerator and denominator are both continuous functions, so we may calculate their limits by substituting in this case, 0. So this would be the cosine of 0 minus 1 plus 1/2 times 0 squared divided by 0 to the fourth. The cosine of 0 is 1. One minus 1 is 0. 0 squared is 0 times 1/2 is 0. So we end up with 0 in the numerator, and 0 to the fourth is also 0. So notice we get the indeterminate form 0 divided by 0. So that tells us that the quotient rule fails. However, we have some hope that this limit may still exist, and we can try to evaluate the limit by invoking LHopital's rule. LHopital's rule says that the limit we started with is equal to the limit of the derivative of the numerator divided by the derivative of the denominator. The derivative of the numerator, the derivative of cosine of x is negative sine of x. The derivative of negative 1 is 0, plus the derivative of 1/2 x squared is just x, divided by the derivative of the denominator is 4x cubed. Now if we try the quotient rule again, the limit of negative sine of x plus x as x approaches 0 divided by the limit of 4x cubed. These are both continuous functions, the numerator and denominator, so we may again evaluate the limit by substituting in 0. So negative sine of 0 plus 0 divided by 4 times 0 cubed. Sine of 0 is 0. 0 plus 0 is 0. 4 times 0 cubed, also 0. Another indeterminate form. So, since we're still in the realm of the numerator-denominator being differentiable, and we get an indeterminate form 0 over 0, we can apply LHopital's rule a second time. So by LHopital's rule, we get the limit x approaches 0, the derivative of the numerator, the derivative of negative sine of x is negative cosine of x, plus the derivative of x is 1, divided by the derivative of 4x cubed would be 12x squared. Again, applying the quotient rule, negative cosine of x plus 1. The limit as x goes to 0 divided by the limit of 12x squared as x goes to 0. You may notice that the power of x in the denominator is getting smaller each time that we apply LHopital's rule. So hopefully we're getting somewhere here. But alas, this time we still get 0 over 0. Remember that the cosine of 0 is 1, so negative 1 plus 1 would be 0. 12 times 0 squared is 0. So let's keep going. Let's try the LHopital's rule again. So again, by LHopital's rule, we get the limit as x goes to 0 of the derivative of the numerator is the sine of x. The plus 1 goes away. Now 12x squared, its derivative is 24x. We take the limit of the sine of x as x goes to 0. Divided by the limit of 24x. as x goes to 0. Sine of 0 divided by 24 times 0. Sine of 0 is 0. 24 times 0 is 0. Again, indeterminate form. However, L'Hopital's rule one more time should get us there. So the derivative of the sine of x is cosine of x. The derivative of 24x is simply 24. So now when we take the limit of cosine of x divided by 24, we get the cosine of 0 divided by 24. Cosine of 0 is 1. 1 divided by 24 is 1 divided by 24. It's a perfectly fine number. So we have had to use L'Hopital's rule several times, but eventually we ended up finding out that our limit is equal to 1 divided by 24.